some of the common things we mentioned before, but let's just go through them again. So common noise generators, anything with a switch mode power supply. So even switch mode power supplies that run ham equipment. I think there are quiet power supplies that you can buy that are switch mode that are HF friendly. So I think, I'm not sure in the US, I think Antron is a good power supply.
Armatron.
Sure.
Yeah.
Armatron.
Well, they also make linear power supplies, which are less susceptible because the power supplies that we use most of the time, people buy $100, $150 power supply, and it's pulse width modulated or switch mode power supply. You can buy power supplies that have a frequency tuner on them, so it would actually change the pitch or change the frequency of that fundamental in that square wave that I was talking about. It'll move that to a different frequency. So like you're using your power supply on 20 meters and it's a problem, you turn that knob and now it's not a problem on 20 meters. Then you go into a different frequency and it may or may not be a problem. You have to turn it again. So you have to watch out for that stuff. And I'm sorry, you were talking about like, you find like laptop power cords are definitely something that people will have problems with. And what you do now, this isn't an over example. This is a giant toroid. Most of them are not this big. But you would take something like this, a smaller ferrite toroid like this, and then just wrap the power cord through it a few passes, and that will help kill the signal or attenuate the signal that's traveling through that cable. Then you plug in your laptop, and the problem goes away.
That's an awfully big roid you've got there, Ape.
Yeah, I think this is
a doctor about that.
I think this is right. I think this is a 4-inch toroid. That one's probably 2.4 inches, the one you've got there.
Yep.
This is a mix 31, so these come in different mixes, and different mixes do different things. These respond to frequencies and will work as an inductor or something to stop current. This is a mix 31. This is generally used for filtering on the HF bands. I bought this, and let me tell you something, it wasn't cheap. Because when I tracked that problem down, I expect it to be something with a big fat porky power cord on there that I'm going to have to wrap through here about 10 times. Whether it's the refrigerator or whether that's the dryer or the washing machine or something like that. Something like this, I'll easily be able to get multiple passes through it. And that way, whatever the device is, let's say it's the washing machine, it's still going to generate that sound. But this will help suppress that sound from getting into my power grid or coming through that wire.
How do we know what is the best choke to use for the particular application? And what I've actually got is here, I've got a very handy website. So this is qrm.guru, and this is an interesting one. So this basically asks these questions. How do I know if the ferrites I purchase are good, bad, or totally ineffective? And if you go through and you read this article, and I'll put a link down in the description below.
eBay.
Yeah, I'll put a description. I'll put a link in the description below. But basically, there's all these studies. Now, these are Australian brands, but if you take the mix type and you have a look and see what they are, it's effectively the same stuff that you can get across the world. So here it shows the effectiveness of split rings versus ferrite rings, which ferrites are best to use on what frequencies, how many turns you're supposed to use.
Correct.
And, again, what mix should you use for what particular application, how many you need to use if you use these split ones, and a summary. So rather than us going through and reinventing the wheel, I'd recommend going through and having a look at this article, having a good read through, and even just checking out just in general that website, because there's some very good work on there in regards to trying to find the right ferrites to use.
That's cool. I'll check it out. I did a video about 2 years ago now. And it's called like Toroids, Balance, and Chokes or something like that. And it's 2 parts. And in the second one of the things I did is I took a bunch of toroids like this and I wrapped wire around them and I connected it to my Nano VNA and I did a through test on there while shorting the ground out. And what I was able to do, right. So what I was able to do is I was able to show that Mix 31, which is something we already knew, right? But like I wanted to kind of prove it to myself was what worked best. Also, I wanted to eliminate, like, One of the things that drives me insane about ham radios is people will hear something, take it as gospel, and they don't investigate it, or they don't realize that it may not be true. And one of them was the powdered iron toroids, the red toroids. And somebody was saying that the red ones worked fine as chokes, and I was like, no, they don't. They definitely do not. So the material that these are made out of is like nickel and zinc, and it's called a ferrite. The powdered iron are made out of powdered iron in the center of them, and they're typically made for inductors, and they have a much higher Q. So when you're looking to make a choke that's broad banded, so like when I build a choke, I want it to work, say, from 40 meters all the way through 10 meters without having to change or use a different choke or a different antenna or any of that kind of stuff. If I use something like a powdered iron toroid, I may not get that broadband capability. I may be able to get the same level of attenuation. I think that you went around somewhere around 30 dB. People will argue 20 dB, 30, 40. I think 30 is generally accepted as okay. But I can get that across multiple bands with ferrite. I cannot with powdered iron. So from my perspective, powdered iron is fine for things like bandpass filters
Transformers.
or low pass filters and stuff like that, where I needed to do it to work at a very particular small slice of frequency, not huge swaths of frequency.
Yeah, that's right. Because most of this stuff is very broad banded, especially as you say when it's on HF. Because you mentioned in your story about the 10 kilohertz all the way up the band, you want to be able to cover that effectively across the whole range of the spectrum. So,
right.
I guess so toroids are your friend. So the first thing is to check your own radio system first. So add the correct choke or the correct toroid to your station equipment. So choke your RF coax line, choke your DC power cable, your USB cable if you have one. So things in the shack and related to the radio. And then once you've done that, you can go out and you can start to look at choking your wall warts. As we mentioned before, you've got the DC lead, which ends up being an antenna. You've got the lights, so LED lights. Obviously, you can't add, in most cases, unless they've got their own separate transformer, you can't add a choke to a light. So you're probably going to have to replace them with a reputable brand.
Just throw them in the trash.
Throw them in. Yeah, because I bought some cheap. I've bought some cheap LED lights over the years, and I bought some from China, and they were horrible. You turn them on, and you just get hash all over the HF band. So I went to my hardware store and I bought Philips brand and put that in, and it was fine. It had no interference at all. So then I knew, okay, well, I can trust the Philips brand and those ones. And they were a little bit more expensive, but it was worth it because you didn't have the issues.
Well, my wife just went out and bought. So downstairs in our first floor, we have a lot of spotlights in the ceiling, and some of them had blown out, and she wanted to replace them all. But when you replace them, you have to replace all of them because they'll come back in different powers, and you might not get the same brand, and they look different. So she bought all these lights, and she came back and she put them in. I went downstairs, and it looks like you're outside because the color that they emit is like that cold blue LED color, like you see
daylight,
or like in parking lots and stuff like that at night. And I'm just like, what in the world? We're obviously going to have to replace them, but we used to get incandescent lights, but now the only thing that you can buy are these LED lights. Now these will be fine for putting in the spotlight out back or something like that, but it's not gonna. I can't have it in the house. It's just a weird color.
Televisions are a different story, especially plasma TVs. They seem to be big issues in the home. Other things to look at would be lights, so down lights, LEDs that we mentioned before. LEDs, same sort of thing. They have little switch mode PWM power supplies that usually drive the LEDs and turn them on and off. Solar panels, and as you mentioned, even things like the oven and the clock and the clock on the oven. So and the dryer. There's just basically any electronic device in the home can be a culprit.
Yeah, this is one of the things I was going to show. This box is not going to show up very well. It's a 3D printed box that I made, but you can see that I have SO239 connectors on either side. And in here, I've got a toroid with some, I think this is 14 gauge magnet wire. And I should have somewhere around 9 or 11 turns, something like that. But what I did is I built a bunch of these, and I would put one in between my tuner and my radio. And that doesn't sound like it makes a whole lot of sense, but the thing is I could have common mode current passing between my tuner and my radio. People say, well, how's common mode current getting into your tuner? Well, it could be coming through the power jack on my tuner that's plugged into my radio that's getting power from my UPS, right, that's plugged into my wall. Or it could be getting it through the control cable that goes from my radio into, now I'm stopping the transfer of it on my antenna line, not those cables, but I did wrap the power cable that goes between the two, with the toroid as well, to help kill any potential suppression that happens in there. But I would just want to make sure that, I'm not getting anything coming in off of the tuner that could be coming in on my antenna system. The tuner is part of that. But I also write on the output of the tuner before the coax that runs out to the yard to the antenna, I have another choke similar to this that I use there. And then I have another choke out at my antenna feed point. So technically along the coax trip, now there is a tuner in between that, between my radio and my antenna, I have three chokes. Some people are like, holy smokes, Abe, that's a whole lot of chokes. But you can suppress common mode current at one end of your coax. I've run 100 feet of coax. Probably not the best idea. But anyhow, so I run this coax out there, and I might suppress it at the antenna feed point, but then I could have new common mode current happening somewhere along the length of that coax that now I need to deal with once it comes in the shack.
Yeah.
So like some folks say you should put a choke along your coax every quarter wave of the lowest frequency that you're going to operate on. So like if you're having an 80 meter dipole antenna, for example, you should have a choke every 20 meters, which seems crazy.
Or just shorten your cable if you can.
right. Just get a shorter cable.
Yeah.
Well, a lot of people don't realize that not effectively choking your antenna basically turns your coaxial cable into an element of your antenna, and it can radiate and it can pick up sound and do all kinds of crazy stuff.
Get to know your neighbors is a very good thing. Probably rather than, if you're going to go and speak to your neighbors and say, look, I think that there's something in your house that's interfering, probably just explain it and say, look, there's potentially a device that I'm looking for that's interfering, and I've had a look around through my house, and I'm just trying to see if it's a little bit further out, and maybe say, if I find it and it's something that might be in your house, I'm worried about interfering with you. And then that way you take it away from, rather than them being the problem, you take it on that you don't want to be the problem. So for instance, if it's a charger or something, you can say, if I transmit, I don't want to interrupt your charging or cause a problem. If I can find the problem device and rectify it for you, then it's not going to be, an issue for both of us, sort of thing. I think
until there's the neighborhood dispute 2 years from now, when they're like, he's a ham radio operator, he's blasting signals into space, and
he's ruining my insulin pump. I can't get my pump to work.
Bro, it's busted. My pump is busted.
I don't know my pump. Did you like that? That was a good impression.
Yeah, it was pretty good. I live on the corner, and when I would sometimes put antennas up in the backyard, I haven't done it in a while, especially because the new FCC rules required me to do a bunch of paperwork. But I was experimenting with a lot of antennas about 2 years ago, and I would put them up, and people would walk by, and they're sitting there pointing, like, trying to figure out what it was. There was one guy that was out there taking pictures of it, so I walked out, and I'm like, "What's up, man?" And he's like, "Oh, hey, what's that?" I'm like, "It ain't nothing. Don't you act like you didn't see nothing." No, I told him, I said, I just explained to people it's a short wave antenna, for listening to far away stations, because most people, don't know what ham radio is, or if they do, they're like my grandpa used.
You talking to aliens out there, are you?
Right, my grandpap did that, and yeah, something like that.
Is that still relevant today? Do you really need those antennas?
Right. Well, that's why I just use wire antennas. And a lot of people are always like, well, why are your videos on wire antennas? It's because it's what I work with. If I put a big old antenna, my HOA is going to go nuts, and everybody's going to get upset at me.
So I guess neighbours are an entirely different thing. But yeah, if you can get on with your neighbours, then definitely do that. One thing that we didn't cover was interference from power poles and power transformers and power companies. So there's lots of different interference that can come directly or indirectly from power lines. Some of the things that I think about are when you get dust and you get dirt get blown over power lines, they can cause arcing, and you can hear the arcing in your radio.
Bad or loose connections in power lines.
Yeah.
Do the same thing.
And usually, what happens is when it rains, it dissipates, or it's not as strong as it would be if it's dry. That's one thing to look out for. The other thing you can do is you can find noisy power poles by just walking around with an AM radio or a direction finding antenna and a 705 or whatever. And if you've got a big rubber mallet, you can actually hit the base of the power pole, if it's a wooden pole, to sort of vibrate it and to shake it, and you can hear the changes in the noises, and that way you can identify what pole it is.
I didn't know that you could do that. You may get a little bit of trouble.
I don't know if it's legal. Don't get into trouble.
He's hitting that pole. He's hitting that pole.
He's got a big old sledgehammer smashing down that. Huh? He's just scared on the phone. I got some.
I seen him.
I got some wacky guy with a SmokinApe shirt out here just whacking a pole.
and end up getting a little bit of trouble there.
Yeah. You'll be on the front lawn, going with a 5-0 back to the.
Yeah. Well, like I've seen these things where you plug something in and it's got like a big parabolic dish and you point it around, and supposedly it's good for hearing some of that. Now we do have a transformer for our neighborhood that's out in front of my house, and I was sweating that being the particular problem. A lot of times you call the power company and they'll come out and they'll take a look at it. But a lot of times they send the kid out, right? The guy's 19. He's first day on the job, has no idea what he's doing, how to use any of the equipment that he's got. And we didn't find anything, sir. So the American Radio Relay League actually has resources that you can contact that help you if you get into a dispute with the power company or something along those lines, help you identify what the problem could be.
Yeah, definitely escalate it. So the first point is to get the power pole. Most of them have a number, or they have a plate on there, and then that way you can identify it to the power company and say that this pole is I believe is what the issue is. If you do a lot of that, I find if you do a lot of the hard work, at least in my state, if you do a lot of the hard work and then you tell them, look, I think this is a problem, they are more than willing to come out, because they don't want infrastructure that's old and is causing problems, because it's not only your ham radio stuff that it could interfere with. It could interfere with a whole bunch of other things. I think
like that insulin pump.
Yeah, or television, even someone's TV, and then there's all sorts of problems there. So they're quite keen to fix those. I had a power pole again at my remote site actually, and it was interfering on VHF and UHF, and I suspected that's what the problem was, because you could hear the hash and the noise. So what I did was I rang up the power company, and what they ended up doing is I framed it in a way, and I said, look, there's because I was the only one that noticed the problem. And I said, look, this is an essential communication site, and we're
right. This is a service. I'm providing a service, life or death.
A service, that's right. And they come out, but see, the transformer on that pole was really old, and they just replaced the whole thing because it was just easier for them to do that. And then they knew that was good for another 10, 15 years or whatever. So, your results may vary depending on where you live, but I've not had too many issues with the power companies here.
I haven't had any, so I'm thankful for that.
And if you're lucky to live in a street that has underground power, then you're pretty sweet, because you don't generally have issues with underground power.
Yeah, unless it's the transformer box. Like, because sometimes you can even hear those boxes winding up or winding down
when you walk past them. Yeah.
And like the thing is that it can be really demotivating for a ham, like a new ham. You go out and you buy this radio and you put your antenna up and you're like, I'm going to be making contacts, bro. Look at me, I'm cool.
Yeah.
And then
Yeah.
you flip it on, and then you've got an S9 noise floor. You can't hear a damn thing. You really don't know where to start or what to do at that point, because a lot of times people think it's just normal. Be like, oh, that's how it always is.
Mm.
I always feel bad. Like I'll see somebody who post a picture like in the Discord, and their noise floor is so high, or their waterfall is like white. Because there's so much hash or something like that. I'm like, yo, you need to Toroid something, son.
Yeah. And sometimes it's completely unavoidable because you just live in a
Yeah,
place where everything's out of your control. So
like
I
apartment
guess
buildings and stuff.
yeah, so you can do certain things like maybe build a magnetic loop. Loops are always good antennas for reducing noise.
Right.
Low noise. They're not that efficient when transmitting, but they're good on receive. So sometimes you can have, if you've got enough space, you can have maybe a loop antenna for your receive antenna, and then you can have a coax switch and switch over to a transmitting antenna, and then you can switch back and forth depending on how noisy it is, if you can or can't hear the station.
Yeah, so to that point, and I don't know, you might want to cut and slice and dice this up in the video, but like you were talking about the loop antenna, and that got me thinking. So loops are very high Q antennas, right? They only work on a very small segment. So when you look at if you were to look at a sweep of it, its resonant points, you would just see a very small V like that, not like a big dip that you would with other antennas.
Yeah.
People love them because of that. Because one of the things it does is it stops from hearing all of the other noise. So earlier we were talking about how you hear more RFI problems on HF than you do on higher bands like UHF or VHF. You do have smaller antennas when you're on UHF and VHF. And so my understanding is that they pick up less noise and stuff because they're smaller. There's less opportunity. When I've got an 85-foot piece of wire running around my backyard, it's a much larger antenna. It's broadbanding, and it hears all kinds of stuff. Now, I use my radio to filter that stuff out to get the signal that I want, but that doesn't mean that my antenna is not picking up all of that noise, and it's the combined aggregate of all that noise that drive that noise floor up, and also potentially pick up those other pulse width modulation frequencies or any other noise being generated by some rogue component.
And if you're interested in building loop antennas, then probably a good place to start would be go to Spider-Man's YouTube channel, Peter Parker VK3YE. He's got a lot of loop antennas, and he's even got a little portable loop that he walks around on the beach in the water with. So,
have you built a loop antenna?
I have built I actually had an 80-meter full wave loop. And I had that when I was living with my parents, because they had plenty of room at their property. I had a 80-meter dipole, and I had some interference. I just couldn't. If I was there now, I probably would easily be able to find the interference because I've gained a little bit more knowledge of the process and looking at that sort of stuff. But back then I couldn't find it. So what I did was I built a full wave 80-meter loop. And I did that very thing. I just had a coax switch, and I would switch over to that. And it was great because the background noise would just completely disappear, and you would be able to pull in signals easy. And then when I was transmitting, I would move over to the dipole. The only problem that I had was when I was talking, sometimes I would forget to move it back over. And someone would say, "Oh, your signal's gone way down in the well." Now I'm doing an American accent for everyone. Your signal, your
hey man.
Yeah, your signal's gone way down in the noise. I can't hear you. Oh, hold on a minute. Let me switch back to the dipole. But yeah, I've built a loop before. It's they're pretty good.
Well, a lot of radios will come with the option for a receive antenna, so you can do just that. A lot of people will use a horizontally mounted RX loop for receive only, and then transmit on a different antenna. So that is a potential option that the folks have there. And that way you don't have to worry about switching your switch every couple of seconds.
Yep. And I have done a video on an MFJ noise canceller, which is basically just a phase noise canceller. So you basically have two antennas that plug into that, and then you adjust the phase between the two to eliminate the noise or the direction from the noise that it's coming from, external noise anyway. So that can vary. It depends on where your noise source is coming from, but it can help.
That looks like a pain in the butt to set that thing up.
Yeah, it's very fiddly, but it does work in some situations.
Well, I've seen people have a miracle with those things where it's eliminated noise, but you have to have the second antenna out in the yard. And to me, I was just like, I'll find a new hobby. I'll take up finger painting or something, pottery.
That'd be a very interesting one. In actual fact, a lot of your videos, you're demonstrating something. So I guess finger painting would go down quite well, wouldn't it?
Would work out. Right, the new direction of the channel is we've gone finger painting.
Yeah. So you got, what is it? Cider, flashlights, and finger painting.
Right.
None of this ham radio stuff. Yeah, so the QRM, it can really wreck with your radio. Well, the Ape and I have had many, many issues with that. So check us out over in this video. Join us over there and we'll tell you about our stories. Crikey.
Perfect. Oh, look, you just cut to me.